All right, so I'm here at CMU introducing someone who's sitting in Italy right now for a mostly audience from people in Seattle, which is so fun. So also these are my students, so say hi everyone. Yeah, so we're really excited today to have, I think, our final speaker in the Morality and AI talk series that Sydney has been organizing, that I've been helping with. And really excited to introduce Laura Weidinger, who is currently at DeepMind as a senior research scientist. You may know her, as Nicole said, from her really influential paper on the taxonomy risks of large language models. But Laura does much more than that. She is also really well-versed in cognitive science and philosophy. And so I think if you joined late, you can still see what was shared in the chat earlier, but there's a really exciting new preprint that Laura has on sort of morality and AI governance and perceptions of people on those topics. But today she's going to talk about the ethical risks of large language models because we're predominantly an NLP audience. So yeah, really excited to have you. Take it away, Laura.
Thank you so much. And thank you everybody for having me and for coming to this talk. I will say that I've scoped my work into this talk to be really about evaluation of these ethics risks of language models. But as Martin said, I'm also working in some other kind of domains. And so really excited to have a discussion in the Q&A of about whatever you guys want to, wherever you want to take it. But let's start at the beginning. So yeah, thanks very much for having me. My name is Laura Weidinger, and I'm a research scientist at DeepMind in a team that is specifically focused on ethics. And so my primary work interests are around studying the implications, social and ethical implications of technologies we build at DeepMind, and in particular studying them in a way that can feed back into the actual design of these kinds of technologies. And of course, a key part of that is evaluation. So I want to talk about evaluation ethical risks from large language models today. And the way I want to talk about it is roughly 3 parts. So one is going to be around the ethical and social risks of harm from large language models. This will be in a lot of overlap with the paper Martin referenced. So if you've seen that paper, the one thing that'll be new for you is actually listing some of the mitigations in a bit more detail. In the paper, we're kind of talking about the risks, and I'm going to talk about the risks in the first section of the talk, as well as some of the mitigations to the risks. And then I'm going to move on to actually talking about how we evaluate ethics risks in language models, which is a non-trivial kind of question. And I'm going to map out the existing evaluation approaches. And finally, we're going to see that there's some real gaps in coverage of what we can evaluate in terms of the risks that language models create. And so I'm going to propose some avenue towards closing that kind of gap. And that's going to require us to expand a little bit how we do language model evaluation. Okay, but to first kind of start off on the right foot. Obviously, we're doing these language models because they do also promise great benefits. And so to just think about what I'm excited about in this context is, I mean, firstly, there's the most obvious application of basically a more powerful personal assistant that can kind of solve mundane problems for you, like drafting an email or scheduling an event, but also can provide maybe information and can provide new access opportunities towards digital technologies. I'm also really interested in kind of generative AI for art. This is a book that was co-written with GPT-3 and a generative art piece from an image generation model. And then one thing that I think these models can do really well that I'm excited about is they can synthesize huge amounts of information, and more than sort of humans can hold in their working memory. If I'm doing a literature review, there's no way I can parse a certain amount of data that these language models effectively can synthesize. So I think that can be an interesting thing for science and research to make use of. And of course, I'm focusing on language, but a lot of what I'm talking about applies to multimodal models. And as we plug in language models to robotics, to image generation, to video generation, there's a whole range of potential downstream applications that we can imagine, including in the clinical context, that could be really useful. But I said I will focus on ethics risks, and so that's what I'm going to do. And for those, I'm now curious how many people have actually seen the paper. But for those who haven't seen it, essentially the way that this part of the talk has come together is through a large research effort within DeepMind, where we did a mixed methods approach, hosting kind of workshops with researchers, essentially asking them two things. So what are the types of risks that we're already seeing in the field of language modeling? And then the second question is, what kinds of risks can you imagine if you just think one step ahead? You know the capabilities of these models, maybe they're not in the wild yet, but what are the kinds of risks that we should really be anticipating in the near future? And putting the kind of risks together that have come up in these horizon scanning workshops on the one side, and then complementing that with a really broad-ranging literature review spanning kind of political science work and law, but also NLP benchmarks and safety research. And so from this work, we came out with a way of parsing essentially what is a really complex risk landscape. And we tried to make it digestible in a taxonomy for practitioners. And that taxonomy has 6 risk areas that I will now take you through in turn. So the first risk is one that's probably familiar to anyone here that's doing NLP research, right? So discrimination, exclusion, and toxicity includes all the kind of harms that come from models reproducing harmful language that they've been trained on. And I think AI bias is sort of really well-known and well-discussed topic, which doesn't mean it's resolved. What's maybe less often discussed is this challenge of exclusion, which comes with, for example, notable omissions. So a language model that gives you 10 stories of a superhero and never makes the superhero a female character, or a kind of a language model that assumes someone called Alex is always male, kind of thing. So these are some of the challenges that feed into this that belong into this category. And on mitigation approaches, these are some of the main ways in which these risks are currently being mitigated. Firstly, we have classifiers that are applied to either the input or the output to essentially filter out input prompts or outputs to avoid toxic language or reproduction of stereotypes and things like that. And here are some examples listed, but there's also human feedback that can be used for this, especially in the more borderline cases or when we want to learn from different communities on what's offensive in their context. And then a second way of addressing this problem is around data set curation and documentation. And I know that, I don't know if Jesse is here, I've spoken to him before, and he's in your organization, and he's just landed a big, important research piece in the Washington Post last week on data set documentation, I think, on kind of giving more transparency on what these models are trained on. So the idea here is that you would essentially not train on some of the really toxic inputs to then reduce toxicity and output of language models. And finally, there's some approaches to prompt design, which is one way to approach many of these risks, and it works to some degree, but it doesn't fully solve the root problem. So then the second area of risks is information hazards, which comes from the model providing output that is sensitive and true. For example, leaking private data that's present in the training corpus. And mitigation approaches here could, in theory, include filtering out private information from training data. But as models are currently trained on huge data sets, that's not really tractable and not done. So instead, what is mostly being pursued is algorithmic innovations, for example, differential privacy algorithms applied to the training data to essentially not allow the leaking of private data. So you can contrast information hazards with misinformation, which are risks that come from the model providing false, misleading, or poor quality information that can be particularly harmful in the context of, for example, giving medical information or legal advice. And this is a kind of harm that shouldn't surprise us at all, because these models are trained to say what's likely, and that's not the same as saying what's true. So the mitigation approaches here that I'm excited about are around citations, so giving actual references that would support a kind of statement from the model. But we've already seen that the models fabricate citations too, so it's not a straightforward thing to actually apply, but I think it has potential. And another thing that I'm excited about here is about new model architectures. So divorcing the training corpus, sort of libraries and so on, from the actual model. So you kind of train a searcher model that is called that then retrieves the information from the sort of library. So really what the model is trained to do is to search more efficiently through the database, but it's not trained on the data itself. It doesn't include it in its own parameters. And what that means is you can update the information corpus without having to retrain the whole model. And it allows for example, having more up-to-date information, but also filtering out kind of the kinds of training data you don't want there. I'm moving a bit quickly because I feel like probably most of you have seen this paper to some degree. So hopefully this isn't too quick for those who haven't. The fourth category of risks is around malicious use. So these are the kinds of risks that arise from people trying to use the model to cause harm actively. And this includes something like writing scam emails, writing malicious code in code assisting kind of tools. And one thing we've seen all over the New York Times kind of mainstream news is obviously on homework and faking kind of exam submissions and things like this. And so what are the kinds of mitigations that we have here? Well, the primary thing really is to monitor use and release the model in a responsible way, trying to prohibit people who are trying to create disinformation campaigns, trying to identify them and not give access to the API. And there are also some ways of doing adversarial training or adversarial testing to try to prohibit really malicious kind of use cases. Oops, jumped. Oh no, this one doesn't seem to have the animation in it. So you're seeing the mitigation at the same time as you're seeing the risk. That's fine. So far, we've talked about the harms where some kind of benchmarks exist, right? And we kind of are familiar with them. We know that there are some automated evaluation tools we can use. And now I'm turning towards harms that are not typically evaluated during model training. And that's a problem that we will come to later. So here we're talking about harms that arise when a person directly interacts with a language model or with a conversational assistant that's built on top of a language model. And these risks arise especially where the human user takes the model to be human-like. And this includes, for example, starting to overly trust and rely on the model where this is not safe, overestimating its competencies, becoming vulnerable to nudging and manipulation by the model, and doing things like giving away more private information than you otherwise would. And we're already seeing this risk. I'm sorry, you can't see it so well now because of the animation, but we're already seeing this risk particularly affect vulnerable groups. So what you can see here on the left, in theory, is screenshots of the GPT-based tool that is accessible on Snapchat, which is an app, used by teenagers and above. And essentially, you can now chat with this My AI GPT-based interface that then has been found to provide a bunch of really harmful kind of advice. And that's really concerning and affects vulnerable groups in particular. And then what we would see on the right, if it wasn't blocked, is this case of a Belgian man committing suicide after chatting to an app called Eliza that is also built on a GPT API, and essentially is a vulnerable person that has shared kind of concerns, and these have been amplified through the chat so that they committed suicide. So really, we're seeing here a lot of these kinds of problems, and what I will say is that mitigations here are really lacking. So existing mitigations include that these agents say something like, I'm just a language model, or that there's some aspects to product design. For example, the model shouldn't refer to itself as having a body or refer to itself with a pronoun I. But really, the problem here is that these language models are optimized, especially in the context of language agents, to sound human-like. So we shouldn't be surprised if people take them to be human-like. And I think the sort of space of what is actually what good looks like here is really underexplored and currently subject to debate. For example, should a model be perceived as anthropomorphic? Should it have empathy? These have been topics of discussion. And again, we have a bit of an animation issue here, but the sixth risk area is on environmental and socioeconomic harms. So these are the ways in which language models impact broader social and environmental systems. This can range from kind of large energy requirements to train a model, to creating creative content that can effectively cannibalize their creative economies because it's cheaper to produce than the content that comes from actual artists, and also automation risks fall here. And so basically think of these kinds of harms as the ripple effects of language models in the real world. And a common pattern here is that groups that already suffer a lot of disadvantage in the economy or in society are usually disproportionately bearing the cost of these risks, whereas groups that are already advantaged are usually the ones to reap the benefits. So these are the systemic effects. And on the mitigation approaches, I mean, there's some ways to, for example, increasing energy efficiency during training. It's not clear that this actually really helps because it might just mean that more people are training larger models in a paradox called Jevons paradox. And of course, there are regulatory interventions to, for example, implement kind of to enforce copyright, essentially. And there's research on how we can have just transitions or just implementations of AI given these kind of broader systemic effects. But I would say that mitigations are very lacking in this case too. Okay, so that was a speedy tour through this taxonomy for anybody who wasn't in the detail before. And the goals here were to inform public discourse and help organizations that actually want to release these kinds of models make responsible decisions, and also to guide mitigation work. So that's why we published this work in 2 papers. One is a really long paper. If you're really working on this and you're interested in the detail, you look at the first option, which is 50 pages. And if you just want an overview of the risks and mitigations, then you look at the second one. Okay, now we're in new territory. I want to turn to how we actually evaluate ethical risks and where our current methods actually need more work. So why do we do evaluation in ethics and more generally? Well, evaluation helps us assess different risks and so can help guide our prioritization of different mitigation work. What do we actually need to work on first? How big is this given risk? But then once we have a mitigation in place, we need to understand whether it's been effective at all. And we can't do that without good evaluation. So we need to sort of evaluate a model before and after a mitigation has happened to see whether an ethical or social risk has actually been effectively addressed. And then thirdly, a really important function is that of gatekeeping. So essentially we can set thresholds and say a model that violates this criterion or a model that has a failure rate that is above X isn't safe to use. And this is especially important for people and organizations that release models, so that it's kind of a guiding framework for when these models actually can be released. So this is why evaluation is actually at the heart of doing ethics work on AI. And I think that's often overlooked. I'm not sure exactly how AI ethics work is organized at the Allen Institute, but in my opinion, evaluation has to be really at the heart of what happens in these teams and in that research. So evaluation can kind of work in 2 main frames. There are 2 main frames for it. There's the one which is evaluation for auditing, and this is really around kind of gatekeeping, evaluating a model after it's finished, maybe even if a third party does it. The goal here is to provide transparency on limitations of the model and to give a sort of single evaluation. And then on the other mainframe, you can think about evaluation for iterative design, where the primary purpose really is to feed back into the training and feed back into the design, feed into the fine-tuning. And this is usually done by the organizations developing the model or the researchers developing the model, and can be done during fine-tuning and multiple times, also between training runs, for example. So I'm focusing primarily on evaluation for iterative design now and in my work, because I operate inside an organization that builds language models. And so, and my goal is to inform design as we go. So that's context for what's to come. So I'm going to take us through 3 prevailing modes of evaluation. And what I mean by prevailing modes of evaluation is that it's currently best practice, if you're going to release a language model, to do some of these tests And we're going to look at what they are and then what the limitations are of this current approach. So the most obvious one is benchmarks. Everybody knows benchmarks. Initially, language models were only evaluated in this way. And we're increasingly seeing an explosion of benchmarks with different metrics. So for example, in addition to some initial scores, we now see things like a truthfulness score, toxicity score, or something like a morality score of a model. And the main advantage of benchmarks is that they allow comparing models, but that's also due to their kind of main flaw, which is that they reduce this complex space into a single metric. And that means that we can compare the models, but it's really hard to understand why they fail, how they fail, and to get an intuition for how they really operate and what they cannot do. Another big problem is that they're lacking context. I know Martin's looking at this. I've actually cited one of his papers here, and whereby sort of hill climbing against a single metric in a single benchmark means that there's a risk of aggravating another harm that is maybe covered in another benchmark. For example, hill climbing against toxicity can mean that then minority content is flagged more often. And another paper I've linked here, the Diaz et al. One, is one where last year we were looking at the case of drag queens posting on Twitter, reclaiming slurs as markers of kind of empowerment and getting flagged left, right, and center because of this lacking of context, to give you a sense of what I mean by these limits of these kinds of benchmarks. And these tests are obviously mostly automated tests, and that can be contrasted with the second prevailing mode of evaluation, which is around adversarial testing and red teaming. That's often done by human evaluators, although that's at least initially done by human evaluators, and then maybe there's efforts to automate these kinds of solutions, to automate adversarial testing based on data from human annotators. So really what adversarial testing usually is done for is kind of to cover more bespoke criteria for them, for which there's no benchmarks, maybe violations of a company's content policies, or to cover violations that would be extremely costly, that would maybe create a large legal or reputational damage. And because human eval is considered the gold standard, that's how these cases are kind of dealt with. Problems here and limitations are that usually adversarial testing is done by very narrow populations. So people like Amazon Turk workers or people who happen to be working as content moderators or content annotators. And that means there's blind spots that pervade then the solution space. So adversarial testing detects some problems but doesn't detect others because of the demographics of who performs these tests. And of course, it's very slow and very costly. So it's not necessarily something that can scale very easily. Okay, and then the third mode of evaluation that we're often seeing, it's maybe a bit bold to say it's a prevailing mode because it's sort of emerging, I would say, is that of psychology experiments applied to language models. And we've seen behavioral tests already for some time in simulated embodied agents in 2D worlds or in 3D environments. For example, there's the Animal AI Olympics, DeepMind Arcade, and other kind of game engines that allow you to run sort of psychology tests like a lab maze test, for example, with an AI system. And this was usually the kind of cognitively inspired AI that was tested in this way. But now it's a growing space and many are tempted into it because of the human-like appearance of language models. So there's now ways to, for example, put card tasks that are from cognitive psychology directly imported into AI into a text format. So the prompt would be something like, imagine I would lay down 4 cards in front of you and they look like this, and essentially framing this behavioral test as if it were a text-based vignette, and then getting the model answer and pretending that model answer is indicating an actual behavior. There's a paper that I'm citing here in PNAS that's come out that is trying to do this with a whole battery of cognitive tasks. And the problem here is that it's very tempting to do this, and of course there's a great potential reward, which is that we can look beyond single metrics from benchmarks, and we can really probe and explore the capabilities of these models. But the problem is that we might just be importing tests that have no validity when they're applied to language models. So it's really questionable to think that a sequence prediction model is really going through the motions that you need in order to, or that you can find something out about its reasoning by giving it tests that were established for very different kinds of systems, cognitive systems. And I mean, at worst, we might be using kind of psychological terminology and applying it to these language models and just confusing ourselves and creating really misleading kind of findings. I think one indicator that these tests often don't work is just that results are so brittle. So for example, in this card task I was explaining that people have put into a vignette is that then if you just change something that should be really arbitrary to the task, maybe the color or something like in the description, the model performance suddenly drops. And that might indicate that the model has learned the original answer from having seen descriptions of this task in its training, or that something else is going on that basically you're not evaluating what you're looking to evaluate. Okay, so these are the prevailing modes of evaluation. Now let's think about how we wanted to evaluate ethics risks in language models, right? So how much progress can we make against that, given these modes of evaluation? And I would say, if you look at the dotted lines, that means we have some way of applying existing evaluation tools to the kinds of risks that we've identified, at least there's some way, whereas the full lines mean that we cannot use the prevailing modes of evaluation to actually address, to even test for these risks. So if we think of, for example, discrimination, exclusion, and so on, there's some benchmarks, there's adversarial testing that can roughly work. Information hazards, similarly, adversarial testing is often used. Misinformation, there are some benchmarks for this. And on malicious users, there's, again, adversarial testing that works. So as you can see, there's sort of two approaches that are really lacking coverage here. And those are human-computer interaction harms and environmental and socioeconomic harms. And in the time that we have left, I want to focus on human-computer interaction harms, because I do think we can make progress here. So first, and I'm now going to talk about this third section, right? So how can we actually close this gap? So why is human-computer interaction missing? Why can we not evaluate any of the harms that arise where I was talking about, human trusting the model too much, or confiding private information, or misunderstanding its capacities, relying on it in unsafe situations, and so on? Why can we not study that with the three prevailing modes of evaluation? Because this requires studying the human side of an interaction. So does the person overly trust the model? Does the person overly rely? Has the person been persuaded or changed their beliefs? Do they now hold a misinformation kind of belief, or so on? So these are all questions about psychological effects in the human. And so they cannot be done by studying the model. And so how do we actually study those? I think we need a human-centric approach to evaluation that needs to be added to anyone who really wants to responsibly test potential risks from language models and mitigate them so that they can then release models that are responsible. So what would that actually look like? I think this is a three-step approach where first we need to kind of study the psychological effects I just mentioned in a kind of controlled conditions, like in a psychology lab, under tightly controlled conditions, looking at how people interact with the model and how it changes the sort of different mental attributes that I just mentioned. And then we need to look at different demographic groups. So earlier I showed you the disparate effect on vulnerable groups, where teenagers and this person, or people with mental health vulnerabilities, for example, are just differently affected by talking to language models or by engaging with these models compared to other populations. So we need to have an explicit protocol to actually look at different kinds of groups. For example, are younger people, elderly, more vulnerable, things like that. And for that, we need an infrastructure for open-ended testing of our models before they actually get released, to capture harms that we weren't expecting in a kind of safe and sandboxed environment that also allow us to identify users that maybe are potentially experiencing harms we weren't expecting, so we can have follow-up interviews with them, for example. So this is what I'm currently working on and what I think are directions for future work. I think there's 3 steps that need to happen. So one is, in language model evaluation, we need to, in addition to what we're already doing, and in addition to fixing some of the limitations of the prevailing modes of evaluation, we need to start really leaning on human-computer interaction methods to study psychological effects on humans. And that we can't really get around studying the human. Maybe in the long run, we can simulate some psychological effects with high fidelity, but currently we can't really get around to studying the human. And luckily, these methods already exist. It's just that they're not routinely applied to language models. And it might be that we find completely new effects compared to previous research on chatbots or whatever, if we actually study them in relation to language models. And then secondly, what we need is to kind of build the frameworks and forums to engage different user groups for safe testing, including vulnerable groups. And finally, we need to, like I already mentioned, create technical infrastructure. So there's work on structured access and structured transparency of models that would allow people to plug into the models, to use the models in a way that is sort of trusted by all parties. And with these 3 ingredients in place, I think we can make human-centric evaluation a standard addition to evaluation suites. And I think it's essential for anyone who wants to responsibly deploy kind of interactive models, especially language models, but also ones that have multiple modalities. So I'm going to conclude on what I've been talking to you about. Firstly, I tried to convince you that kind of mapping a broad risk landscape in a way that is parsable and creates some structure is a really useful first step towards actually identifying the kinds of risks, prioritizing between them, and starting to mitigate them. And then I was telling you that, in my opinion, mitigation cannot work without evaluation. And that means evaluation has to be at the heart of doing ethics work in AI. And there are existing evaluation approaches that are doing some of the heavy lifting already for us to help us understand what risks are. But they do have really important limitations that apply both to metrics, also the validity of different tests, and especially to coverage. And to close one important gap, which is coverage of the human-computer interaction risks or human-AI interaction risks, human-centric evaluation needs to become a standard additional part of the toolbox of anyone building language models and hoping to release them. So that's me done. Thank you. Looking forward to the discussion.
Cool. Thank you so much. I think there's a bunch of questions, but I'm wondering if I should give a little bit of we've been doing this as a format where there's a discussant from internally at AI2 that kind of just talks a little bit after the talk. So I might just do that for like 2 minutes. And then please keep your hands raised for questions. Yeah, I think so. The goal of our series too is to kind of like bridge the gap between like external speakers and like what's going on within AI2. So obviously, you've heard from Sydney and I before your talk about sort of the stuff that we've been doing around Delphi and sort of pluralism of values and things like that. But within the broader AI2 community, I think, and honestly, NLP in general, like a lot more people are thinking about developing sort of like, smaller versions of like these large language models, or just, doing it for more specialized purposes. And so I think there's a lot to be learned from what you were talking about. However, I do think that we're finding ourselves in kind of an impasse in terms of the toolkits that the people, have. And so, HCI is not typically represented as much in the NLP, predominantly NLP groups and things like that. So I'm wondering if you could speak a little bit to like sort of, are you encouraging people to sort of like learn quickly, or if you think there's sort of like gatekeeping that should happen, like you should do this only if you have this kind of background, or things like that?
Yeah, that's a really great question. So I think some of it, so interdisciplinary work is hard, and I think we're not going to get around some interdisciplinary work. So I don't think someone who has no background in psychology or HCI research should take it upon themselves all alone to design these kinds of studies. But I also don't think that we can kind of, as an NLP community, wait for psychologists to come and do the evaluations downstream. I think the reality is that not, so that I think there's two reasons why this evaluation has to happen kind of in-house. One is that the delay between developing a model and other people being able to use it and evaluate it is real. And if you really want to feed into training, you need to kind of do these tests during evaluation. So I'm not talking about the auditing type of tests, right? I'm talking about the kind of what can feed back into training, what can feed back into our design. And so I think it is important to have some kind of way of doing the tests early enough that this can happen. So I don't think it should be something that, let's just leave the outside psychology communities to actually do this. I also think that outside psychology communities often don't have the access they need. I was talking about structured access to models. So obviously, there's some models are out there, but in only some ways, and then other models aren't out there at all. So I think access isn't there for other people to actually evaluate these models meaningfully. I think there's a skill and information delta that also exists. So how did these models actually work, and how can we evaluate them? That's knowledge that for example, you have in your institution. So that is an important part of how you can make these evaluations work. So in terms of my concrete pitch, it would be to partner with people if you don't have the expertise in-house. I don't know if you do. Partner with people who have psychology and HCI expertise and really lean on those partners for methods. So what I was saying here about that, I think this is the important part. Like, these methods exist and they're not applied to LLMs. So finding a way of absorbing that method and getting it to work for LLM. Why is that interdisciplinary work? Because these sort of psych evaluation methods as best practices we need to import, but the exact experiment design will have to be invented, right? So I think there is an interdisciplinary space where some psychology expertise can help in terms of best practices for running experiments, but it has to happen in the organizations that build the models.
Yeah, thanks. That makes a lot of sense. I should also mention, thank you, Nicole, for reminding me that Jesse's leading a project right now with Yanai and some other folks on documenting sort of what is in the big data of these large language models. And so I'm wondering, like, if you could speak a little bit about the sort of transparency piece as well.
Yes, so I think I mentioned Jesse's work in the talk earlier, right? So I mean, I applaud the article that came out in the Washington Post earlier the week. So I think documentation is essential for any third parties also to start having a sense of what's going on. And there's sort of, I think, two papers that kicked off much of this was the paper on model cards, so describing what a model can do, and the data sheets, so describing what is in training data. I wish we had more in the public domain about training data sets and there's different reasons why there isn't more in the public domain. I think it is correct that we need to have more transparency on this. What the right level is of transparency is probably to be discussed. So is it, a description of the training data, or is it access to the training data? What is actually useful to whom? I think, a regulator needs something else from an NLP researcher in terms of having transparency. So I think there's different levels of transparency and of interpretability of the information that are necessary. I think we are seeing models that push out organizations that push out large models provide some kind of results of their analyses, like model cards and some results of their analyses of the data set. But I think ideally we would have some kind of structured access to also the data set. Maybe not the full disclosure of the data set, but some access for researchers to start probing it.
Yeah, I think I agree with you a lot. I want to give a chance to anyone in the audience to ask questions. So please raise your hand and unmute yourself. Go ahead, Sydney.
Hey, can you hear me?
Yeah.
Is this working?
Yeah.
Yeah. Okay. Awesome. Cool. So yeah, I mean, I obviously completely agree that when people interact with language models, the best way of figuring out how what those interactions are going to look like, what people's experiences are, is to use the discipline that has been designed to study people, namely psychology. Though I was wondering if we could just think a little bit more about using the discipline of psychology to study language models themselves, which we started talking about right before the talk. And Martin, I'm also curious about your thoughts about this. So on the one hand, like often these kind of benchmarks for psychological development are designed with humans in mind. And we have a sense of when humans, like for instance, like young children pass a certain task, they more or less have some particular competence. And then the question arises, like when if a language model were to pass that task, can we like also say they have that competence or not? And I think like one of the specific like kind of snags in using psychological paradigms that I've come upon, and specifically trying to like translate my work in cognitive science to language models, is that it feels like we do a lot of work on the psychology side that like never ends up in the paper, right? Like if we're trying to develop a task, we discover there's like 175 different ways that like the task doesn't work. And what counts as doesn't work like varies a lot based on what you're trying to do. So like, for instance, I have like a recent paper where I'm trying to figure out if kids use a particular kind of moral reasoning, and for various like things that I needed to control, the case needed to happen in secret so that nobody else knew it was ever going to happen. But it turns out that when kids hear that something is happening in secret, they're immediately suspicious of it. And so we were getting floor effects. Like no matter what we did, it turns out like kids thought it was problematic. So it turns out we had to do a lot to like get the kids to understand that even though it was secret, it wasn't necessarily problematic. And like once we figured that out, the effect emerges. And so one of the things that I'm wondering is like, what are the sorts of like issues like that language models come up with? So what I've seen when I like give my stimuli just directly to language models, they'll often just like, you know, respond like similarly across the board, no matter like what the particular manipulation is. But if you like realize that you can like tweak the scenario this way or that way, like suddenly again, it seems like the effect emerges. So like what are we to like learn from that? That, oh, they do have this competence, but you have to like make sure that stimuli are tuned for them, or they like basically don't have the competence at all, but like you somehow manage to like get it to seem like it had the competence in the right scenario. Does that question vaguely make sense?
Yes, it does. It totally makes sense. So, and I have an answer to it of my perspective. So if the question is, you know, we're seeing different failure profiles or different performance profiles of language models on cognitive tasks compared to humans, but we're not seeing just that they fail them all the time. We're seeing some kind of profile. So is there a signal in the noise? And I would say that I really appreciate, for example, one philosophy of science paper that I can share on behavioral signatures that is basically arguing, you know, the real signal in psychology testing or in testing animal cognition is in the mode in which animals fail at intelligence tests or something like that. So maybe a primate can succeed, and in one iteration of the task fail. And this is where we start understanding a bit more about the underlying mechanisms of how this primate maybe processes some information. Maybe they fail when the stimuli is presented black and white versus in red and green, and we can start learning something about their vision. So I do get that. And I think there might be some signal in the noise on how language models perform on these tasks. I would say that the problem is that we probably just need new concepts for how language models might reason. And so my answer here is like twofold. One is, I think if we take language models to be a kind of cognitive system, then it's still not a cognitive system like a human cognitive system. We know that the architectures of language models are in a particular way, and it's just not what we know about human cognition that maps onto that. So if it is a cognitive system at all, if there is something going on that we can study, then in order to study that well, we need to develop new concepts for it. We can't just take the human concepts and slam dunk them onto it. Like, oh, working memory, that's how we test for that. Like vision, that's how we test for that. Language models just operate differently. So we need new concepts. And I think especially in the more cognitive types of AI, this is how I would approach this kind of problem. I would say that in the context of language models, I'm not sure that there's much cognition going on. So they wouldn't be my primary candidate for applying psychology tests at all. I'd probably have more hope in some other kind of reinforcement learning-based systems that there's something interesting to discover. And I think the links that were shared before people joined aren't here anymore. So I'm just going to plug a preprint that I sent earlier, which is where I'm talking about, where we are talking about applying developmental psychology tests to reinforcement learning-based AI systems to study their moral capacities.
Cool, thank you.
Go ahead, Will.
Thank you. Thanks. I really enjoyed this talk. I hope this isn't too straightforward or a simple a question, but I'm thinking about the timing issues that are involved with the research and the ethical implications that come from that. The one thing to do with an LLM is we have to build it and get it stood up, then we can study it. But there's a risk of, once it's stood up, that harms can be caused from the model that we've put together. And then it's also, so I guess the question is, how do we do the study and evaluation you're talking about without also causing harm? And one, we don't want to create something that's causing harm or do harm through the research that we're interested in. So I don't know if you have any thoughts on that time. I mean, it's a timing question or that ordering question for doing the evaluation you're interested in.
Yes, so let me just make super sure that I'm getting the question. So is the question around causing harm because if we test on human participants, that very test might cause harm? Or in what way does it relate to the ordering? Can you just tell me that one more time?
Yeah, sorry, I didn't mean to run those two together. One is that we need to create an LLM in order to study it. But while we created it, it's released in some fashion, and it could be doing harm out there in the world while we're doing the study. Another is that, like if I think of the analogy to randomized control trials for drug testing, we would want to have a control group and an experimental group, and we want to be in equipoise between the two. And there is always a risk that we're actually going to do harm, either from not providing a treatment that's beneficial or from the participants who are getting the experimental drug, that it does harm to them. So on that side, maybe it's clear because we have protocols already for clinical studies and trials. Maybe we don't have them here yet. So maybe the question is just the first version, which is we have to have an LLM in order to study it. But how do we put that LLM in the world so that we can look at it and do things with it and run experiments without it also doing damage in the background or to the general public while we're trying to do the study?
Yeah, thanks so much for rephrasing that. So I would say having built an LLM is not the same as having it out there, right? So the way I'm seeing it, or the way it actually plays out in practice at my work, is we have a model that is a sort of starting base model. And maybe then we're going to fine tune it, or we're going to learn and retrain, or we're going to iterate in some way. So with that base model, you do some evaluations, and that doesn't get released anywhere in the real world. And the testing that you do has to be done in very safe ways. So there has to be ethics approval, like of any other psychology study, that any groups that will be exposed to potential harms are that this is done in a responsible way. And there are protocols. So this is my kind of pitch, is like, there are all these protocols in psychology, and there's all this knowledge already on how to do this well. There's all this knowledge on how you run studies on vulnerable groups and manipulating them, and in a way that is actually ethically responsible. So that expertise exists, and that's possible. But I agree with you that there has to be a delay between kind of training the model and releasing it in order for that to even happen. So there has to be a base model that can then be tested, iterated on, and there needs to be time for this cycle to actually occur before a model gets released. And I think I'm actually happy to see that I think of the large AI labs, everybody understands that there has to be some lag. There's discussion on how much lag, but that there has to be lag. I think we no longer have to explain why. There has to be some lag.
Thank you.
Awesome. I have a question here in my office.
Hi, thank you so much for the talk. I just had a question about like kind of the granularity of testing, because like it's sometimes the way the language models are used or like posed as capable of like the task is sometimes more problematic than the language model itself, or like the impact of that is probably more like measurable. So I don't know like how much granularity you should be testing for. Is it just like how they interact with the model itself, or is it like how they interacted with it as a chatbot or like something like that?
Mm-hmm. Yeah, thank you. So that's a really great question, because it's around how do we think about downstream real-world use cases without knowing what the applications will be and without being super specific in what we're actually testing, right? So maybe maybe a downstream use case will be a kind of person using this model as a chatbot to talk to as if it were a doctor or a psychotherapist. But obviously, we want to do these evaluations early on, and we can't study all these possible downstream use cases. So that's why I'm kind of talking about this level of psychological effects. So something like trusting the model too much, sharing private information, overestimating its competencies, changing a belief as a result of nudging by the model. These are sort of psychological effects that can occur through a whole range of use cases. So I would advocate against a sort of super specific, and obviously context will matter, but we cannot now account for all possible contexts. What we can now account for is some early stage design decisions and psychological effects that come with that. So for example, if the model is allowed to refer to itself using the pronoun I, that more often leads people to share private information with it. And this will be relevant in a medical app or in a in a lawyer app or whatever. So I hope that addresses your question, but that's how I think about the level of granularity. I think there will be downstream work that needs to happen, but that's more on the auditing side and less on the evaluation to improve models early on.
Thank you.
Cool. Any other questions? I have a couple, but if anyone in the audience has any. Okay, Yejin, go ahead.
Thank you so much, Laura. This was a really wonderful talk, and I love the super well organized taxonomy, really nicely put together. I was thinking about how different research labs or companies might be able to better address these potential harms. And then I was thinking of this, OpenAI's current narrative, which is that they should be the one who achieve AGI the fastest because they're willing to put a lot of effort into AI safety than many other companies who may not invest as much. And I mean, we all know that, by the way, just off-the-shelf pre-trained language models based only on the raw web data is just toxic, and there are many problems all around, the misinformation and and so a lot of these safeguards are placed basically in the form of either RLHF, RL with human feedback, or even some sort of human demonstration data where they fine-tune their pre-trained models on, in which the human demonstration basically demonstrate how to avoid potentially sensitive questions and then give more lawyer-like answers back. And it seems that this really boils down to, at the end of the day, having more money to pay humans to do very exhaustive preparation of correct answers and very exhaustive testing through human judgments. And I wonder, is there any way to provide this sort of a safeguard for everyone, not just companies with a lot of money?
Thank you. Yes, so there's a lot in that question, and I'll probably address one or two points separately. So I think on this question of where do we get the human data from that we want to align these models to, right? So maybe if I'm in a company that can pay for human raters and annotators to annotate all day, I can do this RLHF more efficiently or effectively, and I can do it at scale, whereas other companies and smaller actors maybe cannot do that. So I think there's one risk here, which is that, of course, if you release the model, then you have free human testing in a way, right? Like you could say ChatGPT is basically human annotating at scale in some way. You get a lot of dialogue data. So that is putting something out in the wild will always be the cheapest option and the least safe option to get feedback, especially if you have some kind of feedback mechanism in that. and it's not necessarily that, and I mean, I'm not talking about OpenAI in particular here, because OpenAI did a lot of RLHF, as you're saying. So I'm not saying that the way they've done it is good or bad. I'm just saying that, of course, releasing the model will always be a much larger data collection exercise than paying for MTurk workers or something like that. So I think if it is the case that large-scale human data is needed, then I don't really see a way around that having to either cost money or be a really participatory effort where users of a system use it. I think there are attempts to try to learn from human feedback in a way that isn't so large scale. So in this other paper that we talked about earlier before the call started, that we published in PNAS yesterday, we're talking about aligning to principles. So can we actually get human feedback on a principle level, on some sort of on a rule level, for example, rather than on each single instance? So you don't have to get annotators to annotate 20,000 prompt reply pairs, but you can sort of get them to annotate a higher level rule and then use that to actually measure alignment too. And that is just one of the possible ways. And this is the paper, sorry, it's a very shameless plug. But that's just one of the possible ways, I think, in which we can maybe try to move away from needing a super large scale annotation effort. I think there's also questions around, well, if we have targeted focus groups, so maybe some demographic groups that actually annotate, can we get a lot of coverage from just choosing wisely, like curating the data wisely that we actually need to annotate, so that we don't need to have thousands and thousands of annotation pairs. But so long as the gold standard is RLHF, I agree with you. It's hard to see how that could work without. I mean, if you want to do it fairly, you have to pay people, and that's going to cost money, or you have to provide a kind of way for people to do it in a gamified way. So yeah, but I think there must be. I think there are other ways to align, and I think focus groups and looking for human preferences over rules or over these kind of higher level principles would be my approach.
Yeah. Thank you so much. But this paper, we discovered it on our own, and we were very excited about it.
Amazing, thank you. I'd love to hear feedback if you come to read it at some point.
Cool. I think we're running out of time, and I want to be respectful of the fact that it's like, I think 8 p.m. in your time zone. So thanks again so much for the amazing talk and the great discussion as well. And thank you everyone for the great questions. Oh, Lorraine, did you have a quick question?
Sorry, that's a mistake.
Oh, you tried to clap. Yeah, okay. You got a thumbs up in it. Yeah.
Yeah, thanks so much for having me, and feel free to reach out to me either on email or on Twitter if you have further kind of thoughts about what I've been discussing. I obviously have outlined future research, so I'm always excited to talk to anyone who's interested in a similar space.
Amazing. Thank you so much. All right.
Thank you. Bye.